Alright, 6.2 says addition and subtraction. When you're dealing with fractions, why should that make you groan?
We have to have the
common denominator.
Common denominator. Lame. Alright, so they point out that you really did learn all of this information already in 5th grade.
But we forgot it. That's a long time ago.
No, we just choose to not remember it because fractions suck.
Fractions are friends. Alright, 2 sevenths plus 3 sevenths. What's that turn into?
5 sevenths.
5 sevenths. Don't try to do anything goofy with the denominators. If you've got 2 out of 7 and 3 out of 7, that means you've got 5 out of 7. We alright with this?
Okay.
Right. What do you do if the denominators aren't the same?
You have to make them the same.
So on this one, what's the common denominator?
14.
How do you turn a 7 into 14?
Times
Divide
it.
by 2. Then multiply the 2 by 2.
So this is really a sneaky way of writing 1.
Which is really just 1/2. Because 4 plus 3 is 7, 14, which is 1/2. Right?
Yeah. Alright, yeah. 2 times 2? 2 times 7? So we got 4 14ths plus 3 14ths, which is?
7 14.
Which does indeed reduce to 1/2. Alright, nothing we're going to do today
Will be that easy.
will be this easy, or will be any different from that. Oh, actually, I guess we could have something like 7 and 12, and we have to work harder to get a common denominator, but this is all we're doing, just fractions, the same process that you learned eons ago. Alright, so, and forgot.
Eons and eons.
Yeah, some of us are older than others, remember?
I was bragging about that in my physics class the other day. He's like, how do you not remember this? I'm like, it was over a decade since I took calculus. What do you mean, how do I not remember this?
My youngest in 5th grade, I'll be doing my homework with him.
Would it be a decade if you were on the moon?
Yeah.
Oh.
If I had been traveling near light speed on a spaceship, it would be different. Alright, we got 3 plus x over x plus 4 over x. They're going to be nice to us to begin with and give us fractions that already have common denominators. So don't try to cancel anything out. Why is it illegal to cancel out those x's?
They're different.
Because they're different.
They're separate. Their parentheses are there, you just can't see them.
Okay, so there's parentheses there, so we'd have to cancel out a whole chunk. What's the word for this? Terms. They're hooked as terms. They're not hooked as factors. You can't cancel anything that's a term. So this problem is actually pretty straightforward. All we're going to do is add, just like 2 sevenths plus 3 sevenths. What's the denominator of the answer going to be?
X.
7 plus x.
Alright, it's going to be 7 plus x, 3 plus x plus 4 if you want to take a step and write that out. Or go straight to the 7 plus x over x. Any questions about that?
No.
I thought we couldn't add them together if there wasn't a 4 plus x. Where is that from? Is that something
You're
different?
like trying to combine a rule about factors, and
Oh,
so
of course.
that's it. They're not
So because we're adding, it's okay.
yes,
Okay.
It's like the difference between multiplying, dividing, and adding and subtracting.
yeah. Okay, this is the basic fractions. We're all right so far. The denominator just stayed x. We just added all the stuff across the top. Combined any like terms we ended up with. Good. Okay. Don't cancel these x's either, for the same reason you can't cancel them over here. This one looks scarier. 4x squared minus 5xy over x squared minus y squared. What does that look like?
Difference of squares.
Difference of squares. Alright, plus 2xy minus y squared over the same thing, x squared minus y squared. So for a second, ignoring the fact that it's difference of squares, let's just go through the addition process. It's already the common denominator, so what's the denominator of the answer going to be?
X squared minus y squared.
Now we're just going to add this stuff all the way across the top. We're going to have 4x squared minus 5xy plus 2xy minus y squared.
So it's 3xy, because you can only add like terms.
almost 3xy.
Minus.
Minus 3xy?
Yeah.
So 4x squared minus 3xy minus y squared
Yeah.
over x squared minus y squared.
Yeah.
Alright?
And then we factor it.
No.
Yes.
We do?
Now we factor it just
No.
like we did in the last section.
Really?
Really.
Thank you.
This, guys, this
I
is
forgot.
like 7/14 over here. It's not reduced.
Oh,
It's got to get reduced.
okay.
So you guys recognize the bottom quickly. What was that?
X plus y. X minus y.
All right, the top one. Let's write this over here. We got 4x squared minus 3x minus 1, if I'm ignoring the y's for a second. So factors of -4 that add up to -3.
Negative 4 plus 1.
All right, so -4, positive 1. So 4x squared minus 4x plus 1x minus 1. Group like so. What comes out of the first group?
4
X.
4x leaves us with
1.
x minus 1. Since that already says x minus 1, what technically came out?
1.
Invisible 1. So our two factors are x minus 1 and 4x plus 1.
We have y's in there still.
We do have y. So when we put it back over here, we're going to have x minus y and 4x plus y. Anything cancel?
The x minus y
How come this x plus y doesn't cancel with
has
that?
a 4.
Because that 4 is in there, can't cancel terms. So our final reduced version of this is 4x plus y on top and x plus y on the bottom. And if you keep those parentheses around them, you'll be less tempted to do illegal canceling. Did you survive this version of this?
Yeah.
Barely? Alright, so we...
I'll have to buy another notebook.
I told my teacher that once. I was like, we can only have 1 page worth of notes today. I'm out of paper. She kept going anyway. Alright, so kept the denominator the same, added the stuff across the top, and then reduced the fraction, which was factor and cancel. Alright?
Yeah.
Alright. So, function version next. What should you automatically start thinking of when it's a function problem?
Domain.
Domain.
So we're going to have something that cannot equal something.
Correct. So we got f of x equals 4x plus 5 over x plus 3. And this is our first subtract problem, and life is going to be a nightmare from here on out.
Lovely. Such a positive thing to say.
You gotta change all the signs.
Yes. Guys, this subtract is an invisible -1 that's got to get distributed to everything. Like
On
over
the
here,
top and at the bottom?
just the top. Over here, when there was a plus, this 2xy was a plus, and this stayed what it was. When you are subtracting, all bets are off. Like, everything changes. We got f of x equals, what's going to be the denominator?
X plus 3.
X plus 3.
On this one, we're going to have 4x plus 5, but when you are subtracting, you subtract this and subtract this. You got to think of it like distributing a -1 through. So what's going to be going on there?
Negative x plus 2.
Where do you think the mistake always happens?
Plus 2.
The plus 2. 99% of the mistakes on this upcoming test are going to happen because of that. People are just fine writing subtract x, but it's subtract all of that. It's subtract this entire chunk. So you've got to change the signs of everything that's up there. Easy, easy, easy to forget to do that. Especially when you've got some monster 12-page problem that's got 87 steps in it. It's really easy to forget to do that. Right there, though, major spot for mistake. So, like, start your little internal self-nag now. Don't miss that.
And it'll always just be the top. You won't ever apply it to the bottom because it's the same, right?
It's like a -1 is being multiplied to a fraction. So it's like a -1 over an invisible 1. So the positive one goes to the
Stays,
bottom.
Okay.
But if it was on the top and the bottom, then it would be positive again.
Yeah.
Yeah. Okay. You could actually think of it as on the bottom because -1 divided by the 1 is the same as +1 divided by -1. But if you multiply it onto the bottom, these aren't going to match
Well, they
anymore.
won't cancel out, right? Okay. Or go together.
Yeah,
Not
they wouldn't.
cancel out, right.
They wouldn't have a common denominator. You wouldn't be able to do the problem.
So it's just the same if I was to rewrite that as plus -x plus 2 over x plus 3, and then do like what we did over here?
Actually, that's a really good idea. If every time you see a subtraction problem, you take a step and change it into a plus problem by doing a -x plus 2.
Oh, yeah.
If you take that step, it would be a good chance to help yourself avoid a mistake. Alright, so we're ready to simplify this. Or combine line terms, at least on the top. What do we have?
3x plus
7.
3x plus 7 over x plus 3.
Yep.
Does anything factor out of the top?
No.
But
Therefore, nothing's going to cancel.
x cannot equal -3.
And so this is going to be our final answer, so we'll say x cannot equal -3. At what point do you check for the domain?
At the beginning.
The beginning is a good place to start looking for it. At what place do you record it?
What the end?
In your hands.
You record it at the end.
Yeah.
Alright, there was something I said between two steps.
Before you cancel.
Before you cancel, but after you
factor.
factor. After you factor is where you're going to have all of these in chunks to look at. And then before you cancel them so that you don't delete one. Alright.
Oh, okay.
This one had nothing to delete and nothing to factor, so right there at the end was when we did it. Good? Alright.
This is gonna get worse.
This is, yeah, okay. Here's where it gets worse.
When the denominators aren't the same.
Yes. Before we get right into problems where denominators aren't the same though, we've got to go through this process of finding the least common multiple of algebra stuff. Like,
Would it just be foiling whatever it is together, or?
you can do that, that's a good way to do it if it's a binomial. If it's a monomial, there's different ways to do it. Because I don't know if you realize this, but when you first learn fractions, to find a common denominator, you often found the least common multiple. Often fractions are small enough you just do this in your head and you don't realize you do this. If you're trying to find a common denominator of, say, 3 and 12, do you remember ever making multiple lists? So like 3, 6, 9, 12, what's next? 15. This list can go on forever. And then 12 would be 12, 24, 36, whatever. It goes on forever. The least common denominator is the least number that's on both of those lists, which happens to be what? So probably you don't do this in your head with 3 and 12 because you know 12 is going to be the least common denominator. But this process, I'm pretty sure you learned somewhere along the way. So if you're trying to find the least common denominator of something like 4 and 15, 4, 8, 12, 16, what's going to be this common denominator?
60.
Yeah, okay, so you're going to have to keep going until you find 60 on both of these lists. That's going to be the first number that's on both of them. The least common multiple is the least common denominator.
I thought you factored them out and then combined them or whatever.
There's a way to do it that
Is
way
way too.
Yeah. Which we're going to kind of do.
Now, in this case, I mean, it's just multiplying them together.
Yeah, in this one because that's the first. Yeah.
One where they cross.
You can actually always do that. Because common denominators don't always have to be the least common denominator. I know that you always think it does, but it doesn't have to be the least. You can find any common denominator. So you can always multiply the two numbers together. 3 times 12 is 36. That number would be both on both of those
But you just
lists,
have to
right?
make sure you reduce at the end, right?
Yeah, that's
So
going
it'll
to
be-
cause more reducing at the end. That's exactly what it does. Okay, so how this translates into algebra version. We need to find the least common multiple of algebra looking stuff. So this one says 21x, and the other one is 3x squared. Now instead of listing out the multiples, there's a shortcut, well not so much a shortcut, but a different way to find the multiples, which is what you were talking about with, isn't there a way to do it where you write their factors? That's what we're going to do. So here's this process. We are going to list the factors of both of these things instead of multiples. Don't get confused since the last list was multiples. We're going to list the factors.
Times 3 times x.
Okay. I'm going to be anal and put them in order just because. 3 times 7 times x. Everyone alright with that? What's this one built out of?
3 times x
3 times x
times x.
times x?
Yeah.
Actually, I'm trying to decide if I want to do this like I do it in my nursing class. Let's make a table.
Your nursing class?
Yeah, we have to find this in my no, it's not got x's in it, but it's really similar. Where we're gonna make a columns for these. This has 3's. What's the next prime number?
5,
5. Next prime number.
7,
Next prime number.
11.
11. So when you factor something, do you agree that it's going to turn into its prime numbers, like prime factors, making those factor trees? Remember doing that?
Yeah.
And since we've got x's, let's also have a column for x's. So what was 21 built out of, now that I've erased it?
3.
3, 7, and an x. What was this one built out of?
3, 2 x's.
3 and x squared. 2 x's, x squared. So, to find the least common multiple, what you do is you look in every column that's got a number in it. So, the 3 column has numbers in it. Which one's biggest? The top 3 or the bottom 3? Trick question. They're the same, right? There's not like one that's got an exponent that's higher. So the least common multiple is just going to need 1, 3. This doesn't have a number in it. 7? So our least common multiple is going to need a 7. Out of the x column, which one of these is bigger?
X squared.
X squared, so pick that one. That is our least common multiple. So then you multiply it all together. Least common multiple, 21x squared. All right, now, this is the monomial version of this.
The who?
The monomial. These are monomials.
Oh, okay. By themselves, one of them. Okay.
Right, they're not hooked to any other terms with a plus or minus. The polynomial version of this looks like this. We're supposed to find a least common multiple of x squared plus x minus 12 and x squared minus 16. So just like over here, we're going to list the factors. They probably don't go into this column idea quite as easily. What does this factor into?
Either 2 and 6 or 3 and 4.
3 and 4? Is that going to be the one that makes it work?
4 is positive.
4 is positive, 3 is negative. Is it eligible for the shortcut?
Yes, there's no leading coefficient. Or the leading coefficient, I mean.
The leading coefficient is 1. So x plus 4 and x minus 3. So envision these, I guess, in like columns. We've got a column of x plus 4s and a column of x minus 3s. What's x squared minus 16 built out of?
Difference of squares.
So it's got an x plus 4 that I'll put in that column, and what's
X
an x,
minus 4.
x minus 4? We don't have one of those.
So then you'd have to multiply the bottom one by x minus 3 and the top one x minus 4.
To get them into being common denominators, yes. Which is the next step. We haven't got there yet. All right, so our LCM, least common multiple. You're looking at
X plus
all of the columns, and it needs the biggest one out of each. And if they're the same power, the same exponent, they're the same size. So it needs 1x plus 4. It needs an x minus 3.
And x minus.
And it needs an x minus 4. Which we should not multiply all together like we did with that monomial one. Just leave it like that. Alright, so far?
And that's the answer for that one?
That's the answer for finding the least common multiple of that, yeah. Alright, so far? So a process for this, let me kind of put instructions to this. What we're doing is we are listing the factors, and I'm arranging them in columns so that if they have matching factors, you can see, like these both had 3's in their factors, so I lined them up in columns just so you could see that they both have 3's. You alright with that?
Which means
Line
you only
these
need
X's
one
up
of
in the
them
same column?
Instead of doing 2 3's, it's only 1 3.
Mm-hmm. Yeah, so you're looking for the biggest exponent on there, and these are both 1's, so that's all that needs to make it into there. This one, there's an x squared, that's the biggest one, so that's the one that needs to make it. If for some reason you had a column that looked like maybe your 5 column, you had 5 and 5 and a 5 to the 4th, what would need to be in your LCM?
5 to the 4th.
Just a 5 to the 4th, the biggest one that's in the column. Good? Okay. All right, how this applies is,
If you do that to make them the same denominators, so that you can add and subtract them, do you need to do anything to the top of
Yes.
the problem?
absolutely.
Whatever you do to the bottom, right?
Whatever you do to the bottom, you have to do to the top. And I'll nag about that when I show you what we're doing. All right, here is our first example of adding fractions that don't have common denominators. And they conveniently choose these two denominators that we've just been working with. We got 2 over 21x plus 5 over 3x squared. So these do not have a common denominator. We need to find a common denominator. And the process for finding a common denominator, one of the processes, there's multiple, is doing this. The least common multiple is the least common denominator. So what we need to do is we need to turn both of these fractions into fractions that have a denominator of 21x squared. This one already has a 21x. What is it missing to get to 21x squared?
An X.
Needs one more x. Whatever I do on the bottom of the fraction, I must do on the top. Otherwise, I'm changing the problem. This is a sneaky way of multiplying by 1. That's all you're allowed to do to stuff, is multiply by 1 and add 0. That's what I mean by sneaky multiplying by 1. It doesn't look quite like 1, but it's going to let us accomplish the rest of this problem. Any questions about this? If you do not do it, guys, this is just like when we were changing, what were we changing? 2/7 into something over 14.
Yeah.
We had to times it by 2 to get it to be 14. We also had to put it on the top. All right, so that's the algebra equivalent of this. This piece,
7
Seven.
and 7.
to turn it into that, it needs a 7
35.
And then a 7 on top.
and a 7 on top. So it'll be 35. So if I like simplify this stuff, I've got, oh, my favorite thing is there's some students, they get to this point and they go back and they're like, oh look, those x's cancel. Yes, they cancel, but that takes you back to that. You're not getting any progress on this. Don't cancel that. You just barely put it there.
Wait, the answer is the question?
So wait.
What the hell is going on here?
I love this math.
Is this a trick test?
All right. So this is what it looks like after I like combine the tops and make them look a little nicer, and combine the denominators and make them look nicer. So what's the denominator in the answer going to be?
21.
21x plus 35 over 21x squared.
And then if we just add across, nothing combined, so 2x plus 35. Just like in other problems, at this point it's possible that something factors out and cancels, but this one happens not to. Did you survive that one?
Yeah. They were all
Oh,
that easy,
sure.
right?
That's the answer, yes.
Alright, that's it. Now, I'm a little worried because the next example, I drew a frowny face, and then I crossed it out. I'm like, oh, we can handle that one. And then I drew a frowny face again, which means I really don't like that, but I should have chosen a problem to do instead.
I say we do it. It just didn't help.
There's something really screwy in this problem. Let's not do that one. Let's...
If you do all the hard problems in class, then it works easy.
It's not going to be easy. We already
Let's
know.
let's do this one instead. Alright, this one says x over x squared plus 9x plus 20.
Which problem is that?
39, I think. X over x squared plus 9x plus 20 minus, oh, watch out, it's a minus, 4 over x squared plus 7x plus 12.
4 plus negative 4. Just change it now.
Just change it now to plus negative 4?
-4.
Alright. So, we need to find a common denominator. Guys, on these problems, you might just want to, well, I'll show you a simpler way to do this in a second. Not a simpler, but like, so you don't have to do so much side work. let's factor these. X squared plus 9x plus 20.
4 and 5.
4 and 5.
So we got an x plus 4, which we can visualize in a column, and an x plus 5, we can visualize in a column. This one says x squared plus 7x plus 12.
3 and
3 and
4.
3 and 4.
So an x plus 4 that I'm putting in the same column with the other x plus 4, and an x plus 3. So that means our LCM, and therefore our LCD, has what?
X plus
X plus
4.
four.
X plus 4,
5.
x plus 5,
And X plus 3.
x plus 3. So what needs to happen is that this x squared plus 9x plus 20 has an x plus 4 and an x plus 5 already. What does it need to turn into the LCD?
X plus 3.
It needs an x plus 3 on the bottom,
And top.
and therefore also the top. This one was already the x plus 4 and x plus 3.
Minus.
So what's it missing?
X plus
X plus
5.
5.
Needs the x plus 5 on the top and the bottom.
Plus 3x.
Alright with that?